Hey guys, so one of the things that you guys asked me to focus on for review for the AP exam was differential equations. And one of the main topics in differential equations is slope fields. Here's a paragraph describing what slope fields are, but specifically the first sentence is the most important, which is a slope vector or direction fields are graphical representations of differential equations. Now, differential equations are really just the equations of derivatives, right, with respect to x and y. And when we're looking at a slope field, it is a graph of all the possible slopes at that derivative for every specific point, okay? So here, if we take a look at this example, it says sketch the slope field for the equation dy over dx equals 3x minus 2. Now, dy over dx, remember, is a derivative. And this table that I've made here is in terms of x, and dy dx, right? So what we're going to do is if we take a look at the slope field, it's the graph with the dots. And since our derivative is specifically just in terms of x, we're going to be paying attention to the x values. On this graph, the x values start with -2 and then end with +2. So all of these x's need to be on our table. Okay, now what you're going to end up doing is you're going to end up substituting the x values into the derivative like so. 3 times -2 minus 2, 3 times -1 minus 2, 3 times 0 minus 2, 3 times 1 minus 2, and 3 times 2 minus 2. And what you're going to end up doing is you're going to find the derivative values for those x values, right? So 3 times -2 minus 2, that gives us -8. When we plug in -1, we get -3 minus 2, which is -5. This one gives us -2. 3 times 1 minus 2 gives us +1. And then 3 times 2 minus 2 gives us that 6 minus 2, which is 4. Okay, so what these represent, these are all slopes that are happening at those particular x values. And what we're going to do on the slope field is we're actually going to graph those slopes, okay? Now, notice that the first slope is -8. It is a slope that's going to decrease, and it's going to be a steep negative slope. So when we graph it, it's going to look something like that. And at every point where x is -2, we're going to have a slope that looks like that. Okay? At -1, the slope is now -5. So it's still decreasing. It's still a little steep, but it's not as steep as -2. Okay, so we're going to draw at all of those points a -5. So a little less steep than at -2. Okay. At x equals 0, all of the slopes are -2. So again, it's still a negative slope, but it's a little less steep. You can do it like that. Now, this is just a sketch, so it doesn't have to be exact, right? At +1, now we have a positive slope, so therefore now the slope has to be increasing from left to right, but it's not too steep. So like that, because it's increasing. And then at x equals 2, the slope becomes 4, which is more steep, and positive is still increasing, so now it's going to be more steep. Okay, so this completes the sketch of the slope field, okay? And why is this important? Because a lot of the time they ask us to find the particular solution to the differential equation. And what that means is that we have to find the specific graph or the specific equation for that differential equation at a specific point. So let's go ahead and take a look at how we do that, okay? Here we're being asked, find the particular solution for dy over dx equals 3x minus 2 that goes through f of -2 equals 2. So now they're being more specific. They want us to find the actual equation for this. And in order to do this, we have